This is about section 6.2. I covered number 8 to number 19. Let me summarize the highlight in this section. We have a right triangle. The Pythagorean formula is c squared equals a squared plus b squared. And in other words, a squared equals c squared minus b squared. So this plus is when this one is a hypotenuse. And this happens when this number a is a leg. So what the difference is, this one is plus and this one is minus. So when we try to get the hypotenuse is square root of a squared plus b squared. And if you try to figure out one of the legs, and then that is square root of c squared minus b squared. The next important thing we learned was opposite and adjacent side. Those are the relevant concept. We know which one is opposite and which one is adjacent only after the angle is determined. But hypotenuse is always the opposite side of right angle. Adjacent forms an angle with a hypotenuse. So this one is adjacent. In this case, this one is adjacent. Opposite is unrelated to forming the angle. And this is just a opposite. And that is not attached to the angle. We learned SOHCAHTOA. Those are the sine, cosine, tangent functions definition. Sine of theta is O means opposite, H means hypotenuse, and cosine is adjacent. A means adjacent, and H means hypotenuse. This one is TOA, means tangent, tangent of theta equals opposite over adjacent. And we also learned about reciprocal functions. Those are cosecant of theta, that is 1 over sine of theta, and secant of theta equals 1 over cosine of theta, and cotangent of theta equals 1 over tangent of theta. You have to have very clear idea about how those are defined. This reciprocal function is very important to know, because when you evaluate with calculator, there is no such cosecant, secant, or cotangent key. But if you use this reciprocal identity, then you can evaluate those by using sine, cosine, and tangents function key. For example, in this case, we want to evaluate cosecant of theta. Then what you have to do is you will get the sine value, and then you will use 1 over x button right here to get reciprocal. We also learned about the special triangle identity, 45, 45, 90-degree triangle. Those are 1, 1, square root of 2. Both are the same triangle, but we denoted it with different mode. One is degree, the other one is with radian. The next thing we learned was 30, 60, 90-degree triangle. Those are 1, 2, square root of 3, 1, 2, square root of 3. In this case, this one is 60-degree, and this one is 30-degree. And this one is pi over 6. This one is pi over 3, because corresponding degrees are pi over 3 and pi over 6. Number 8 is about a straightforward definition of reciprocal function. Let's do number 9. Number 9, we have a right triangle like this, and we have to figure out the 6 trigonometric functions. So we label 13 as hypotenuse because that is opposite of right triangle or right angle. And this vertical line segment is associated to theta, attached to theta. So that is adjacent. And this is opposite. So sine of theta is opposite over hypotenuse. Therefore, that is 12 over 13. And cosine of theta equals adjacent over hypotenuse. So that is 5 over 13. And tangent of theta equals opposite over adjacent. So opposite is 12 and adjacent is 5. And its reciprocal function will be cosecant of theta is 1 over sine of theta. So all we have to do is flip it. So it becomes 13 over 12. And secant of theta equals 1 over cosine of theta. So 13 over 5, again, reciprocal. And tangent of theta equals 1 over tangent of theta. So that is 5 over 12. Let's do number 10. We have a right triangle like this. This is theta. This is 48, 50, and 14. The angular position is different from the previous picture. The hypotenuse is opposite of the right angle, so this one, and 48 is attached to this theta. This is adjacent, and 14 is opposite side length. So sine of theta equals opposite over hypotenuse, and therefore that is 14 over 50. And you can reduce it to 7 over 25, but either one will be accepted. So both are accepted, so you don't really have to care about simplest version. Cosine of theta is adjacent over hypotenuse, so adjacent is 48 and hypotenuse is 50. And tangent of theta equals opposite over adjacent, so opposite is 14 over adjacent is 48. So 1 over sine is cosecant of theta. So cosecant of theta is 1 over sine of theta, that is 25 over 7. And 1 over cosine is secant. So secant is 1 over cosine of theta is 50 over 48. And cotangent of theta equals 1 over tangent of theta, that is 48 over 14. Let's do number 11. Number 11, the first problem is sine of 24 degrees. We have to use the calculator. Currently, my calculator is in radian mode, so I will switch it to degree mode by using DRG button. Now it is in degree mode. So you will put 24 first, 24 and sine. So we get 0.40674 because 6 is following 3. And we have to round to 5 decimal place. The cotangent of 25 degrees, we don't have cotangent function key, therefore we have to use the reciprocal identity. So that is 1 over tangent of 25 degrees. So we put this part first and then 1 over. Currently degree mode, so mode is find 25 degrees of tangent, and then we have to take the reciprocal, so 1 over x. So that's approximately 2.1441. Let's do number 12. The first one is cosine of 33 degrees. So we have to think about the degree. So this is degree mode, and we have cosine button, and so 33 degrees of cosine. So that's approximately 0.83867. Again, you have to be careful about the instruction that requires you to evaluate to 5 decimal places. The second one is about cosecant of 42 degrees. That is 1 over sine of 42 degrees. So we go through the same process as we did here. So we evaluate sine 42. And then this is 1 over reciprocal. Button is 1 over x. So that's approximately 1.49448. Let's do number 13. Number 13 is about secant of 13 degree. We don't have secant button, so we have to use the reciprocal identity. Secant is 1 over cosine of 13 degree. Again, this is a degree mode, so I would evaluate 13 degree of cosine and then 1 over. So that's approximately 1.02630. And the next one is tangent of 52 degree. This time we have tangent button, so we evaluate just a tangent of 52 degree directly. So 52 degree of tangent, that's approximately 1.27994. Let's do number 14. Number 14 looks like this. We have a triangle. This angle is 13 degree. This one is 17, and this one is x. We have to figure out the side length as x. We would think about the angle relationship, and we know that 30 degree is a part of the well-known triangle. So 1, 2, square root of 3, this time 30 degree was on the top. When we think about the relative position of the side, this x is not attached to the, directly attached to the angle, so that is opposite, and 17 is hypotenuse. In this triangle, hypotenuse is 2, and opposite of 30 degree is the bottom leg, 1. How do I use this? These two triangles are similar triangles. So we consider the sine, because opposite and hypotenuse are involved. Sine of 30 degree, because opposite over hypotenuse, opposite is 1 and hypotenuse is 2. In this first triangle, the same sine is again opposite over hypotenuse. Opposite is unknown and hypotenuse is 17. And obviously these two values are the same, so these two must be the same. So x over 17 equals 1 over 2. And so we multiply by 17 on both sides. Therefore, x equals 17 over 2. Let's do number 15. The triangle looks like this. Again, we have a well-known angle, 60 degrees. So we will relate that with a well-known triangle, 30, 60, 90 degree triangle. When we think about the relative position, opposite of this right angle is 43. So this is the hypotenuse. And the angle is formed by this side and this side. This is not associated with that. Therefore, this is opposite. In this triangle, 2 is the hypotenuse and opposite is square root of 3. So we do the same reasoning. opposite and hypotenuse are involved, so that is associated with sine. So sine of 60 degree is what we are interested in. And sine of 60 degree is opposite over hypotenuse. So opposite is x in the first triangle, and hypotenuse is 43. In the second triangle, sine of 60 degree is again opposite over hypotenuse, and opposite is square root of 3, and hypotenuse is 2. Those values are the same, therefore these two values are the same. X over 43 equals square root of 3 over 2. Therefore, we have 2 multiplied by 43 on both sides, and 43 is 43 over 1. Therefore, x equals 43 square root of 3 over 2. Let's do number 16. Number 16 is sine of theta is 5 over 13. Sine of theta is defined as opposite over hypotenuse. If you look at the multiple choice, then angle is located in 2 different positions. So what we will do will be, firstly, I will locate the angle in a 2 different position, and then I would label it with opposite and hypotenuse. Opposite, this is hypotenuse, this is hypotenuse, because those are the opposite of the right angle. And opposite is not attached to the angle, so this is opposite in this triangle. If angle is on the top, then opposite is the bottom leg, because that is not forming the angle. So opposite is 5, so I would label it like this, and then hypotenuse is 13. So we have clear idea about where 5 and 13 must be located. Now I look at the multiple choice, and then when that is on the bottom, the angle theta is located on the bottom, the 5 must be located here. And so this one is the candidate. And in this choice, theta is here, but 5, I even cannot see 5 here. And so this is definitely not the answer. When theta is on the top, the 5 must be on the bottom. This one doesn't qualify. And theta is on the top, then it must be 5 must be opposite. So this is not the answer. And this is opposite, this is hypotenuse, and this is the correct answer. Indeed, you have to check whether in this triangle, the relationship, this relationship is preserved, but by using your calculator. But in the multiple choice problem, this is only the possible answer, and so you don't really have to check it. In this question, we have to figure out cosine theta. So I would label it. So this one is, let me write it big. This one is hypotenuse, and this is opposite. This is 5, and 12 is adjacent. So cosine of theta is adjacent over hypotenuse. So adjacent is 12 and hypotenuse is 13. And the tangent of theta equals opposite over adjacent. So opposite is 5 and adjacent is 12. cosecant of theta is 1 over sine of theta. So sine of theta was given as 5 over 13. So we just flip it. That is 13 over 5. And secant of theta equals 1 over cosine of theta. So that is 13 over 12. And tangent of theta equals 1 over tangent of theta. So that is 12 over 5. Let's do number 17. Number 17 is about cotangent of theta equals 2. We do something similar. In this case, this is cotangent. So cotangent of theta is defined as adjacent over opposite, and 2 can be written as a fraction 2 and 1. The similar situation, the angle is positioned either in the bottom or on the top, like this. So this is adjacent and this is hypotenuse and this is opposite. Okay, this is adjacent because this forms an angle. This is hypotenuse and this is opposite. Opposite is 1 and adjacent is 2. Opposite is 1, adjacent is 2. And we can easily calculate that is square root of 5 for hypotenuse, but I will not calculate it because this is a multiple choice problem. So I will keep this in mind and I will start to look at the multiple choice. So in the first one, the adjacent is 2 and hypotenuse is square root of 5 and opposite is 1. So definitely this is the answer. But let's go through the multiple choice. This is in the angle is located on the bottom, and 2 is located here, but opposite side must be, this one must be 1. So I would cross this out. When angle is on the top, opposite must be 1, but that is not. So I would cross this out. And again, this one is adjacent, not opposite, and so I will cross this out. Similar to number 16, we don't really have to calculate this part because the only option is this one, but we already calculated it. So that is what I am saying is we don't really have to calculate square root of 5 in this problem, and this is the correct answer. So obviously this is the correct evaluation, but it is worth to check like this. Pythagorean formula. Let's do the problem. This one is opposite, and this one is adjacent, and this one is hypotenuse. Square root of 5. This one is 1, adjacent is 2. So sine of theta equals opposite over hypotenuse, and opposite is 1. Hypotenuse is square root of 5. and cosine of theta is adjacent over hypotenuse, and adjacent is 2 over hypotenuse is square root of 5, and tangent of theta equals opposite over adjacent, and opposite is 1 over adjacent is 2. And cosecant of theta equals 1 over sine of theta. So we flip this, square root of 5 over 1. This is square root of 5. And then secant of theta equals 1 over cosine of theta. So 1 over cosine of theta, we flip the square root of 5 over 2. Let's do number 18. We have to evaluate sine of 30 degree times cosecant of 30 degree without using calculator. This tests about whether you know the reciprocal identity. Cosecant is 1 over sine. Therefore, those are reciprocal function. So the final answer is 1. Number 19 is about the story problem. So 400 feet guy wire is attached to the top of the communications tower. And that means this one is 400 feet. And this is a right angle. And the angle of elevation is 75 degrees. What they're asking you is how tall the communications tower is. So this is hypotenuse, and this is the opposite. Therefore, we use sine of 75 degrees because that is opposite over hypotenuse. So we can write it down as x over hypotenuse 400. So we have an equation x over 400 equals sine of 75 degrees. So I would multiply by 400 on both sides. Therefore, x equals 400 times sine of 75 degrees. So let's evaluate it. This one is degree mode 75 degrees of sine times I multiplied by 400. And so that is approximately 386 because you have to round it to the nearest foot. Always make sure that you follow the instruction, even if you follow your math is correct. If you write the answer in the format which is not instructed, then you will lose everything. For example, if you put 386.4, then all the math is correct, but you're not following the instruction, so you will not get any point. So make sure that you read all the questions correct and make sure that your calculator mode is the correct mode.